Welcome to This Explainer. Today, we are diving headfirst into the absolutely awe-inspiring 47-year survival story of the twin Voyager spacecraft. Launched way back in the summer of 1977, these two remarkable machines set out on a mission that, honestly, fundamentally redefined our place in the universe. We're going to explore exactly how they've survived this long, the mind-blowing science they're still conducting today, and the ultimate legacy they're carrying out into the great unknown.
Okay, let's kick things off with a truly staggering number. Over 16 billion miles. That is Voyager 1's distance from Earth right this very second. That makes it the absolute farthest human-made object in existence. No contest. To put that into perspective for you, it has officially crossed into interstellar space, totally leaving behind the protective bubble of our sun. It's out there right now, literally plunging into the cosmic dark at over 38,000 miles per hour, acting as our outermost scout in the galaxy. Just incredible.
Now, to truly grasp the sheer scale of that kind of isolation, think about this. It takes an entire 24 hours for just one data signal, traveling at the speed of light, mind you, to reach our deep space antennas. When engineers back here on Earth need to send a command to Voyager 1, they have to wait 48 agonizing hours round trip just to see if the spacecraft actually received it. Talk about the ultimate long-distance relationship, right? It's sustained by immense patience and some incredibly robust 1970s engineering.
So you might be wondering, how did it even get that far out? Well, let's look back at the Golden Age and a grand planetary tour.
To make this incredible, decade-long tour happen, scientists utilized a super rare gravity assist slingshot. Mission planners basically realized that a specific alignment of Jupiter, Saturn, Uranus, and Neptune, an alignment that only happens about once every 175 years, by the way, would allow the spacecraft to use the gravity of one planet to literally propel it to the next. It's like a cosmic game of pinball. So both Voyagers launch in 1977. By 79, they reach Jupiter, and by 80, Saturn. From there, Voyager 1 headed up and out of the solar system plane, while Voyager 2 kept going, making the first ever visits to Uranus in 1986 and finally Neptune in 1989. And these spacecraft, they didn't just snap some pretty pictures. They fundamentally rewrote our science textbooks. I mean, they discovered the very first active volcanoes ever seen off Earth, right there on Jupiter's moon Io. They peeled back the curtain on Jupiter's Great Red Spot, revealing its swirling counterclockwise dynamics. We got our very first close-up look at Uranus, finding 11 brand new moons and 2 rings in the process. And at Neptune, they captured the furious, raging winds of the Great Dark Spot. It was, without a doubt, an absolute golden age of planetary exploration.
But you know, Voyager's legacy isn't just about the hard data. It also brought us a profound shift in perspective. And that brings us to the era of the pale blue dot.
Once the primary science phase wrapped up, the mission took on this massive cultural weight that really no one anticipated. Back in February of 1990, the legendary scientist Carl Sagan managed to convince NASA to take a pretty massive risk. He wanted to point Voyager 1's camera back toward the inner solar system from a staggering 3.7 billion miles away. Why? To take one final family portrait. Now, pointing the cameras near the sun could have totally fried the equipment, and the planets were going to barely be visible anyway. But Sagan, he knew the philosophical value of such an image would be absolutely immeasurable. Think about what they managed to capture. A single pixel caught in a scattered ray of sunlight. As Sagan so powerfully wrote about this exact image, that's here, that's home, that's us. Every single human being who ever was, everyone you know, everyone you love, lived out their lives right there, on a tiny mote of dust suspended in a sunbeam. It still remains a stunning visual reminder to preserve and cherish the only home we have ever known. But, of course, looking backward just wasn't sustainable. The mission had to quickly pivot to its next crucial phase, surviving the interstellar cold. So to survive crossing what's called the heliopause, which is basically this invisible boundary where our sun's protective influence completely ends, mission planners had to start desperately saving power. The cameras drew way too much energy, and let's be honest, they'd be pretty useless in the empty, pitch-black void anyway. So on Valentine's Day in 1990, they were turned off forever. Out here, way past the sun's magnetic bubble, the extreme cold means the spacecraft has to rely entirely on decaying radioactive plutonium just to stay alive.
Right now, the mission is caught in basically an ongoing, high-stakes game of orbital triage. To conserve a dwindling electrical supply that loses about 4 watts every single year, NASA has had to systematically sacrifice scientific instruments. It's a tough choice. The magnetometers are still active, giving us vital data, but other tools like the low-energy charged particle sensor and the ultraviolet spectrometer, they've been permanently shut down. All of this is just to ensure the essential communication systems can keep running so it can still talk to us.
And recently, the mission actually faced a near-fatal crisis. A buildup of chemical gunk over nearly 50 years slowly clogged the thruster tubes. Now, these thrusters are absolutely critical because they keep Voyager 1's antenna pointed directly at Earth. I want you to imagine trying to breathe through a straw that is slowly shrinking down to half the width of a human hair. That is exactly what happened to these thrusters. And the stakes? Well, if the spacecraft can't point at us, we lose contact with it forever. So, to fix this, engineers executed a brilliantly tense, high-stakes remote rescue, risking freezing the spacecraft's propellant lines just to successfully activate an alternative set of thrusters. They couldn't just flip the dormant thrusters on, right? They were way too cold, so the team had to carefully turn off a vital heater to free up just enough electrical power to warm those new thrusters. They successfully executed the swap and then immediately flipped the main heater back on before the hydrazine lines could freeze solid. Honestly, it was an absolute masterclass in deep space problem solving. And you know what? Those brilliant survival hacks have completely paid off, leading us straight into our current era, persistent interstellar science. Because of those engineering heroics, Voyager 1 remains our single direct window into the space between the stars. It is essentially out there right now giving us our very first interstellar weather report. Even without the massive shockwaves from our sun, the active plasma wave system is picking up the quiet, persistent hum of interstellar space. Scientists are detecting these weak, narrowband plasma waves that literally allow them to track the density of the void in real time. They're measuring electron densities and mapping actual plasma turbulence across 10 astronomical units. It's just mind-blowing that it's still doing this. But we have to face facts. Eventually, the power is going to run out entirely, bringing us to its final chapter, an eternal golden legacy. When the twin spacecraft finally go completely dark, probably sometime in the 2030s, they are going to become ghost ships, drifting silently through the cosmos forever. But they won't be empty. They'll be carrying a 12-inch gold-plated copper record. It is basically the ultimate cosmic message in a bottle. It's this incredible time capsule packed with greetings in 55 human languages, 35 natural sounds of Earth, 115 analog images, and 90 minutes of global music. From the complex music of Bach to a mother's very first words to her newborn child, it is a beautifully curated representation of exactly who we were when we first reached for the stars. So as we wrap up this explainer, I want to leave you with something to really ponder. Billions of years from now, wandering the Milky Way forever, whose hands might finally intercept and decipher our ultimate interstellar legacy? Will it be found by some future version of humanity that has totally mastered the stars? Or maybe by an alien intelligence discovering for the very first time that they are not alone? The Voyager mission is the ultimate testament to human curiosity and endurance. Thank you so much for joining me to explore this incredible journey.